Assalamualaikum warahmatullahi wabarakatuh. Hi 11 graders, welcome back to my video. I hope you all are doing well because now we are going to discuss another topic in this second semester of grade 11, which is about atoms. Okay, I'm sure that you already know atom was considered as the smallest particle in universe. Yeah, we can say like that until the scientists discovered that actually inside the atom we can also discover, or we can also find another subatomic particles, yeah, which are proton, electron, and also neutron. And moreover, right now our knowledge already reached until that inside the proton, electron, and neutron itself we can also divide this particle into more fundamental particle. Yeah, maybe you have heard about what is it, quark, about lepton, Higgs boson, muon, and friends. Yeah, but for today we are not going to discuss about this fundamental particle. What we are going to discuss now is just the atomic model, and then the nuclear number, and then proton number, and what is it, about isotope. Yeah, maybe in chemistry you have learned about this one. So basically in this video it's like a review for you, yeah, to strengthen your understanding and to recall your memory about this topic, because in this topic, yeah, that one that I mentioned is just, what is it, a prior knowledge, so please understand the atomic model. So after this we will discuss about radioactive and so on. It will be easy for us. Okay, if you are interested in this topic, let's watch this video and start by saying basmalah. Bismillahirrahmanirrahim. Alright, let's check it out. Okay everyone, now I'm already open a simulation from PhET entitled Build an Atom. So here I would like to show you a simple atomic model. Yeah. Okay, here we have a bucket of protons, neutrons, and also electrons. Yeah. And yeah, this is the place that I can put the proton, neutron, and electron to build an atom. And in the right side here we have a panel that will show us an element, yeah, on the periodic table that we are created, and also the net charge and the mass number. Yeah. Okay. Okay, for this one, I just now tick the element and neutral or ion, yeah. Okay, so basically for an atom, yeah, at least an atom has a neutron, I mean, and then a proton, okay, and then an electron, yeah. So this is an atom of hydrogen, yeah, and you can see in the periodic table, yeah, the position is here, yeah, and this is the symbol of the element, yeah, 8, and the net charge equals to 0, and then the mass number is 2. Yeah, what is the mass number actually? Okay, let's see here. When I add more neutron, so the mass number increase now is 3. Yeah, and then I add one more proton, so here you see the mass number now is 4. So mass number basically is the number of nucleon, yeah, we call it nucleon. Nucleon can be proton or neutron. So how many nucleon in nucleus? Yeah, you see here, it's now helium, yeah, everyone, and we have 2 proton and 2 neutrons, so the total is 4. So that's mass number, yeah, 4. That means 4 nucleon. Nucleon can be again proton or neutron. Okay, and then here I add one more electron. Okay, yeah, so this is a neutral atom of helium. and this is the symbol of helium, and this is the position of this atom in the periodic table. Okay, yeah. Now I would like to add one more neutron, and everyone, you can see what is it, the change in the element, net charge, and also the mass number. Let's see. Let's start from the neutron. I add one more neutron. Okay, you see, the element still the same, helium. The net charge still the same, 0 or neutral, and then the mass number increased from 4 to 5. Now, so that's correct, everyone. Yeah, so mass number depends on the number of nucleon in the nucleus. Yeah, okay, and then now I'm going to add one more protons. Okay, again, see the okay, I'm not put the protons now. Please observe, yeah, the element, net charge, and also mass number. Okay, I put it now. Okay, you see here, the element now becomes lithium. Yeah, become lithium. This is the symbol, and then this is the position where we can find lithium in the periodic table. And then for the net charge here, yeah, previously is 0, but then when I add one protons, now the net charge equals to +1. Yeah, equals to +1, and the mass number increased from 5 to 6. Yeah, as you can see here, we have 6 nucleon, or 6 nucleus particle, yeah, in the nucleus. Okay, so yeah, I guess you already understand, yeah, about the mass number, but now let's see for the net charge. Yeah, the net charge here +1. Yeah, when I add one more proton, so we can assume that the electrical charge of protons is +1. Okay, now and then when I add one more electron, okay, the element still the same, lithium, and then the net charge now equals to 0. Yeah, previously +1, and then when I add one more electron becomes 0. So it shows us that electron has electrically charged -1. So +1 -1 equals to 0. Now it's become neutral. Okay, as you can see here, we have 3 proton and also 3 electron, and this is the comparison about the number. Yeah, so it's equal number between electron and proton, so that's why the net charge equals to 0. And about the mass number, of course, because the electron is not in the nucleus, so the mass number is still the same, 6. Yeah, electron number, the number of electron not change the mass number. Okay, now I'm going to add one more electron again. Yeah, one more electron again. Yep, you can see here. Yeah, now the net charge is -1, so it's clear for us. Yeah, now that electron has -1 of charge. Okay, so when I add one more proton, it will be, you can guess. Yeah, correct. Yeah, the net charge will be equals to 0. Okay, this is the proof. Okay, you see here, because when the number of electron and proton the same, so the net charge will be equals to 0. And when I add one more proton, what's changed beside the net charge? Yeah, the element also changed from lithium to beryllium. So proton, it's not only changing the mass number. Yeah, previously 6, now 7. It's also changed the element now. Yeah, the element name. So that's mean an element depends on the number of proton. When the number of proton change, so the element is actually changed, no matter the number of electron and also the proton. Okay, now so here we have a neutral atom of beryllium. Okay, I hope you now you understand, yeah, the impact of number proton, neutron, and electron to the element name, to the net charge, and also to the mass number. All right, now the next one, I would like to also show you how what will happen when I add neutron. Yeah, you can guess. Yeah, what will happen to this atomic model when I add one more neutron? Okay, please guess. Okay, correct, yeah. So the element is still the same, still beryllium, yeah. So our assumption before that the element name only depends on the proton seems correct, yeah. So because here when I add one more neutron, it doesn't change the element name, still beryllium. The net charge still the same, yeah. So neutron seems like the name, yeah, as the name imply, neutron, that's mean neutral. So the charge of neutron equals to 0, so it's not impact to the net charge. And then about the mass number, you already understand, of course, when we put one more nucleon to the nucleus, so it will increase the mass number. Okay, now here the next thing that I would like to emphasize here, yeah. So basically, when the element name still the same beryllium, but it has different mass numbers, so we can call this atom as isotope of beryllium. Yeah, isotope of beryllium. So you can define by your own words what is isotope. In my word, basically isotope is an atom, yeah, that has different number of neutron. So when I add one more neutron, yeah, you can guess it will not change the element name and also the net charge. It only change the mass number from 8 to 6, yeah. Okay, you see here, yeah. Sorry, from 8 to 6, from 8 to 9, what I mean, yeah. And then you see here, yeah, as I said, the element name still beryllium, it doesn't change, and the net charge also the same, still 0. So this one is also isotope of beryllium. Okay, okay, yeah. So I think that's all for this video, yeah. The first one, remember, in atomic model we have proton, neutron, and electron. In atom we have nucleus, and we can find proton and neutron inside the nucleus, and then we have electron that orbits the nucleus. And here, remember, we have element name, net charge, and mass number. Okay, we will also summarize in the closing. Thank you. Okay, that's all everyone for this video. I hope you understand our discussion in this video. But before we end close this session, yeah, let's summarize what you get from this video. Yeah, the first one, we were discussing about what is it, atomic model, and inside the atomic model you can find nucleus and also electron that orbit the nucleus, and in the nucleus itself you can find proton and neutron. Okay, so basically in an atom we have proton, neutron, and nucleus, yeah. Remember the charge, neutron equals to 0 or neutral, and then for proton equals to the positive one, and for the electron the charge is negative one. So it will impact the net charge of the atom, yeah. When it becomes positive 1 or positive 2 or minus 1, minus 2, it will become an ion, yeah, not atom anymore. And then about the proton, yeah, it will also impact the mass number, because mass number, I can say that the number of nucleon inside the nucleus, yeah. Remember, nucleon can be proton or neutron, and also proton number will impact to the element name, yeah. No matter the neutron or the electron decrease or increase, but if the proton doesn't change, so the element name will stay the rest, yeah. Okay, and then so when we find a condition when we add more neutron and the elements stay still the same, so we call it as the isotope, yeah, as the isotope. So I think that's all, yeah, everyone, for this video. I hope you understand again, but if you have some question or the explanation in this video is not clear for you, don't hesitate to ask me. Maybe you can by WhatsApp, contact me by WhatsApp, or you can ask me directly in the class, yeah. See you in the class for this discussion, and thank you very much everyone for watching this video. Let's close the session by reciting Hamdalah. Alhamdulillahirabbil alamin. Okay, I close. Assalamualaikum warahmatullahi wabarakatuh. Bye everyone to the next video.